Hello everyone, thank you for watching this video. Now in today's part of the lesson, we're going to look at some of the more difficult questions involving arc length and sector area. And in this part of the chapter, right, you'll be also using some of the trigo skills that we will have learned itself, right? So without further ado, let's begin. Question number 1. The diagram shows a sector OBC of a circle, center O, and radius 23. So now if I have center O over here and this is my radius is 23, that also means that what can you tell about BO? So BO itself is also the radius, which is 23, and we already know that this portion is 8 over here. So AO can be found by taking 23 minus 8. So 23 minus 8, that will give you the number 15. So these are some of the additional information that you can find out from. Okay, and you write them down as you go along while reading the question. Next one, the question says BAD is a sector of a circle, or the typo here. Okay, center A. So I have the sector over here, but they only gave me the radius is 8 cm. There's no angle, so this angle is unknown. So if we were to find anything related to a sector and arc length, we will need to find this angle later. Okay, and they gave us that angle ADO, which is this one over here, is 90 degrees. That means actually we have a right angle triangle, and we are able to use that information to find some stuff, right? So from here, question asked me to find arc length. So if the question is asking me to find arc length, first I'll need to know what is the angle, and I need to find what is the radius. I have the radius already, so that means I need to find the angle theta. Okay, how am I going to find angle theta? Let's take a look at this triangle over here. So we have a right angle triangle. This is AOD. This is the length 15. This is 8. So in order to find the angle theta, what I can do is I find this angle over here first. Okay, so maybe I should change this to, I call it change the name. I'll just call this theta instead. Okay, I'll find this theta first. Okay, so I'll find this one. So if this is my angle, right angle triangle, right? So I'm going to use tuakaso, right? Tuakaso itself. What do we have? I have my theta, and this side is going to be my hypotenuse, and this is going to be my adjacent, touching the angle, right? So A and H. So using my tuakaso, part A, which one do we use that has adjacent and hypotenuse? Yes, we're going to use cosine, right? So cosine goes with the angle. Cosine theta in this case is adjacent over hypotenuse, right? Adjacent, which is 8, hypotenuse is 15. To find the angle, we need to have cosine inverse. Okay, now in this case, this is all in degrees. So make sure your calculator shift menu. Number 2 angle unit is number 1 in degree, right? So shift cosine 8 over 15. That gives me the number 57.769. Right, so this angle is 57.769 degree. I'm not rounding off my number yet because it's not the final answer. So that means, right, this angle over here is 57.769 degree. How am I going to find the angle for the arc BD? Right, so my angle for the arc BD is the one that's over here at this portion. So I'm going to find the first step, the next step, the angle BAD, right, is 180. It lies on one straight line, so 180 subtract away 57.769. I'm sure you're able to get this. And I got 122.231 degree. So after I got this angle finally, right, right? 2D1. Now I need to find arc length. What is the formula to use to find arc length? Try to recall. So we're going to take the angle, which is the angle for this case that we have found, over the whole circle is 360 degree times I want an arc length. Is it 2 pi r or pi r squared? So it'll be 2 pi r. Okay, correct. Okay, and then let's work out this number. And our radius is 8. So I got a number 17.0666, which is around 17.1. 3 sig fig, right? 3 significant figures. cm, 3 sig fig. Have you gotten the answer? Now next they want us to find the perimeter of the shaded region. Let's take a look at the perimeter of the shaded region and analyze this a little bit. The perimeter of the shaded region is made up of a few portions. Number one, I have the arc length, right? This arc length is what we have just found, 17.1. Okay, but the next question is I need to find this arc BC. So this arc BC corresponds to the angle over here. So technically speaking, I need to find this angle. Well, I already found this angle is 57.769. I already know this is 90. So information, number one, first step, this angle over here. Okay, part B, I should do part B here. Number one, angle AOD. That will be 180, angle sum of a triangle. Minus away 90, minus away 57.769. Right? So that, what does that give me? That gives me 180 minus 90 minus 57.769, 32.231 degrees. So this angle, okay, with this angle, then now we can find this unknown arc length over here. So we're going to take this arc length, so arc BC. Again, this is the angle that you're looking at, right? So this is the angle, so you have this and you have this one over here. So the angle that we want will be 32.231 over 360. So arc length, 2 pi r pi r squared. 2 pi, what is the radius? The radius, this is made out of the huge sector, right? So the larger one, so the full radius is the number 23. Okay, let me get my answer. I got a number 12.938. Right, so I'll just write to 5 sig number, okay? So in this case, let me update my answer. 12.938. This one was 17.0666. Now the last part that I need to find will be to close it up, is to find what is this CD. Okay, I know that the whole thing over here is 23 and this part is the one I find. So actually I'm looking for this portion. So remember, we have a right angle triangle, right? So we actually have a right angle triangle over here. So if we have a right angle triangle here, we can use Pythagoras theorem to find this length. So using Pythagoras theorem, this portion DO, this is the shorter side, so you have to do a subtraction. So the radius, the hypotenuse is 15 square, subtract away 8 square. That gives me 161. Square root of 161 to give me 12.688. 6 lah. Okay, around there. Right? So then, in order to find what is CD, right, I just subtract away. So CD is made out of 23. The whole thing is 23 cm. This whole thing is 23. This part is 12.688. So you can find this one over here. Okay, so 23 minus 12.6886, and that gives me 10.3114. Right, so this part is 10.3114. Now we're gonna find the perimeter. We're gonna add all the three sides together. So finally, perimeter will be to add all these three together. 17.066 plus 12.938 plus 10.3114. Have you gotten the answer? I got my answer to be 40.316. Rounded off to 3 significant figure, we will have 40.3 cm, 3 significant figure. Have you gotten the concept? Well, yes, then we should move on to the next question. Okay, let's start with our second question here. Okay, second question, I chose one involving radian. Okay, so before we begin, in case you are not very familiar with the radian formula, so let me highlight a little bit of our radian formula. Okay, radian formula number 1, arc length S equals to R theta. This is for arc length. Okay, and then you have area of sector, area A equals to half R squared theta. Now these formulas can be found inside the formula sheet during examination, so please do use it wisely. Alright, so number 1, number 2, one is length, the other one is area. Okay, and then another one more important thing to take note, okay, for involving radian, we must know that 180 degrees is equals to pi radian. So we have a mental picture. Sometimes we are able to convert angles using this property over here. Okay, so let's begin with the question. Question number 2, inside this diagram, angle AOB is pi over 3 radians. Now remember and take note, right? Pi is actually 180 degrees. So this actually angle AOB tells me this is 180 divided by 3, which is actually 60 degree. So if this angle is actually 60 degree, and these are both radius, right? So this is also 12 cm. That's also 12 cm. That means at the same time, this will be a what kind of triangle? All the 3 sides will be the same, right? So this is actually now an equilateral triangle. So this side over here automatically also become 12 cm. Right? This is an important piece of information. Why they withhold the information, they want me to tell you directly, because they want you to interpret and understand what it means to have pi over 3. So you must remember to use your relationship over here. 180 is equals to pi radian. Use it to interpret the question. Okay, now let's take a look. Continue. Next part of question. OA is 12 cm, which I've identified. AQB, where is AQB? AQB, oh, this portion, this is an arc with a center circle. So there's 2 parts. This is not really an arc over here. BPA is a semicircle, right? A semicircle on its own, so it's slightly different. Then the one that they want is BQA, AQB, right? Center about O. So and this part they tell you ABP is a semicircle, meaning AB to P. This is a semicircle. Well, we already know information. This one here, the length is 12 cm, right? So what do you know about the radius of this semicircle? The radius over here is 12 divided by 2, 6 cm. Wow, let me draw this. Okay, so in this case, just highlight over here radius is equals to 6 cm. Okay, AB is the diameter. So question asks me to calculate AB. Do I even need to calculate? I already know that because this is an equilateral triangle. So AB is directly equals to 12 cm. No calculations needed. Okay, next one. Now let's upgrade our level of the question. Find the area of the shaded region. We have to look at the question a little bit. This shaded region is actually made up of a semicircle minus away the segment. So let's understand our question, our targets. Number one, the area of shaded region is made up of area of a semicircle. Now I'll try to draw as straight as possible. A, B, P. Okay, so this is my semicircle with radius 6 cm. Subtract away a segment. Minus away this small segment. It's not a semicircle, not a semicircle. A, B, Q over here. So subtract away area of segment. Okay, so our targets are very clear now. There are a few things that we need to find. Number one, we're going to find the area of a semicircle. The semicircle has radius 6 cm. So number one, area of semicircle will be semicircle. So you need a half. Area, that will be pi r squared. Pi, radius is 6 cm squared. So area of my semicircle, not a nice number. So I shall round it, put it as 5 sig figs as accurate as possible. 6.5486 become a 9. Okay, this is cm squared. Not the final answer yet, so I'm not going to round it off yet. Okay, next part, I'm going to find the area of the segment. How to find the area of this segment? Now we have to observe. I'll go back to our picture and observe where did this segment comes from. This segment, which is the area over here, right? This segment actually comes from this sector. Okay, so our objective is to find area of segment. This is actually made up of the area of sector, the pizza over here, or rather I call it the ice cream. The ice cream without the ice cream cone. Right, this portion over here, the angle is pi over 3, the radius is 12. Subtract away the area of the triangle, the one in white color. Okay, this triangle over here, and we have half AB sine C. Right, area of triangle. But first, this is all in radian mode, right? Please change your unit, the angle measurement in your calculator, to the radian mode. How do we do that? You want to remember? We have shift menu. Let me write it down. In your Casio calculator, shift menu, choose number 2, angle unit. And then choose number 2, radian. So remember to change it back to degree later after you finish the question. So what do we have now? So this question over here will be area of the sector. Area of sector is which formula? Okay, let's come back to our formula sheet. Is it number 1 or is it number 2? Area, which one is it? A for area, so in this case it's number 2. Area equals to half r squared theta, right? So we will have half radius square, which is 12, and theta, pi over 3. Okay, minus away area of triangle. What's the formula of area of triangle we're going to use? Please don't tell me half the base times height. So what's the next formula? Half AB sine C. Correct. Have you gotten the correct answer? The two sides that's available is A and B, sine pi over 3. Again, make sure your calculator is in the radian mode. Let's calculate this answer. So half r squared times theta. Okay. Oh wait, give me a minute. What's the radius? Is theta shift pi over 3. I got 3982. Okay, and this one over here, this is half times 12 sine. Okay, remember radian mode, fraction pi over 3. I have 62.354. Subtracting each other, we get 13.0442. Okay, but now we got both the information that we want, kcm square over here. So now how are we going to go back to our original main question? Main question asked me to find the area of the shaded region, which is an semicircle minus the area of the segment. So final answer, to get the part to this part of it, we will take area of the triangle, area of the whole semicircle, subtract away the area of the segment that we found. And I got the answer 43.5048. Rounding it off, 43.5 cm square for 3 single figures. Have you gotten the answer? Alright, now if that's the case, we shall go on to the last part of the question. Find the perimeter of the shaded region. Well, this perimeter of shaded region is a little bit easier in the case because it's only made out of one portion, the arc. Remember, it's the arc. Arc, this arc AB. Arc AB has the radius. What's the radius for arc AB? The radius is actually 12, right? And the angle is pi over 3. Right, so we find this later, and the second part we need to find this portion. Okay, it looks really like the ice cream this time around. So this is actually the circumference of half a semicircle, half of the semicircle. So I have not much space, so I should write it over here. This portion over here is half of a semicircle, half of a full circumference. So it's half of circumference, length, so it will be 2 pi. Correct. Okay, so what's the radius of this semicircle? Remember, do you remember what's the radius of semicircle? In this case, this is a semicircle, right? Remember, the radius is, yes, on the diagram, this one is 6 cm. Okay, and we have 18.8495. I should round it to 18.850 then. Okay, and next one we need to find this arc length. Okay, this arc length over here, this arc length is made by the angle over here, pi over 3 and 12 radius. So using the arc length formula, that will be this one, s equals to r theta. Right, so we will have this s equals to r theta. Okay, it's shifting. So this one here will be r, which is the radius 12, times theta, which is pi over 3. gives me 4 pi and 12.566. So finally now, if they want to find the perimeter of the shaded region, I'm gonna add these two together. Okay, you all can write it down somewhere. Okay, but I'm just going to make use of the information that I see on my diagram beside it. So you can write it, present it properly below. Alright, so I add these two numbers together. 18.850. And I have 31.416, rounding it off 31.4 cm. Have you gotten the answer? Now with that, I end off for today's part of the lesson. Okay, please do continue to try the next few questions and the WA1 papers for revision. Now see you, bye bye.